Welcome Math 107 students to the class activity for Lesson 7. Lesson 7 worked on solving three types of equations: absolute value equations, polynomial equations, and quadratic equations that had real number solutions. So the first thing I want to point out is that as you start adding more and more types of equations to your toolkit to solve, you'll be looking at strategies that you can use for some and not for others. So it's really important to be able to keep track of not only the different strategies, but also when can you use these strategies? What must your equation look like? And one of the first things you need to be able to do is to be able to determine when you have a quadratic equation and when you may have, even though a quadratic equation is a polynomial equation, when you might have an equation that's polynomial and not quadratic. So as you can see here, I went through exercise 1 and I just highlighted the 2 in every equation because that's the highest degree, that's the highest power I see. And so we call this a second degree equation. Now, if we just take a look at the next type of equations on number 2, if you look across here, you notice that you don't have 2 as your highest power, you have a 4 in the first equation. So this is what we call a fourth degree equation. And in B, you have 3 as your highest power. So this is what we call a third degree or a cubic equation. Now, there may be some strategies we use in solving these equations that can also be used in quadratics, but we don't have a formula like we do with the quadratic equations. The quadratic equations have the quadratic formula which solves any quadratic equation. We don't have equations that are easy to use for these types. So you need to be able to recognize the type of equation you're attempting to solve. So let's take a look at the three, real quick, review the three strategies we came up with for solving quadratic equations. Okay, we know that the quadratic formula can be used to solve any quadratic equation, any one. But sometimes using the quadratic formula and simplifying it can be a little intensive algebraically. So if you can use another method that may be quicker and easier, then let's go for it. The other method we looked at, one of the other two methods we looked at is called the zero product property. So you know from looking at zero product that you're going to have a multiplication problem that's set equal to 0. And this idea is, okay, take your entire equation, put all of your terms on one side and set the other side equal to 0, and then factor one of your sides. Then you know that each factor must equal 0 to find your solution. And then the other method we talked about was the square root property. Okay, just a real quick summary here. And the square root property looked like this from your previous page. So if you have something squared, now that u could be anything. It could be a simple variable like x, or it could be an expression like 3x plus 7, parentheses, we say quantity 3x plus 7 squared equals a constant. And you can go directly from that form to your two solutions. U equals plus the square root of c, and u equals minus the square root of c, because you're using the square root property. So let's take a look at this first equation. When I look at A, I think of this property right away because I see I have a constant on the left side, a constant on the right side, and I have something squared, a perfect square on the left side. So I can go immediately from my original equation to x equals plus or minus the square root of 49, which is plus or minus 7. So my solution set is negative 7, 7. All right, so as you can see, you might say, wow, why don't I use that whenever I can? Part of the problem is sometimes students will forget. I see it over and over. They'll forget the negative square root. They always get the positive one, but they forget the negative one. So if you have a tendency to forget things like this, you may want to try to use your zero product property. Okay, you can solve this equation with all three of these methods. So this one was your square root property. And now we'll take a look at the zero product property. All right, so that says you need to have 0 on one side or else you can't do anything. So I'm going to subtract 49 from both sides. And the minute I do that, this sets up for a quick, hopefully a quick factoring problem for you. Okay, so this is what we call the difference, because it's subtraction, between two perfect squares. But even if 49 wasn't a perfect square, let's say it was 50, you could still use this method, because in the first term in these parentheses is the square root of x squared, and the second term is the square root of 49, which in this case is 7. And because it has no middle term, you know that your operations have to be opposite. One's a plus and one's a minus. So the minute you set each factor equal to 0, your solutions pop right out. So here you would subtract 7 from both sides, so there's x equals -7, and here you would add 7 to both sides, so x equals 7. So when you use this factoring technique, it pretty much guarantees that you'll always get both answers. And of course, you could use the quadratic formula, QF, big QF, by first putting your equation into the general form where you have 0 on the right-hand side and A equals 1. B is 0 in this case. To see that, you could have written this like this. 0 times x is 0. And C is -49. But again, this involves a lot more work. But for some of you, you may feel very comfortable with the quadratic formula, so you can go ahead and use it. In any case, you have two solutions. All right, now the next problem looks like, maybe this is set up to use a quadratic formula because I have 0 on one side and all my other terms on the left side, and I can immediately see A is 4, B is 12, and C is 9. And so you might just think, okay, I'm going to use my quadratic formula, the opposite of B, B squared, 144 minus 4 times A times C, all over 2 times A. As you can see, you'd have to kind of go ahead and do some work here to get to the answer, but you can do it. All right, so again, I only like to use the quadratic equation, the quadratic formula, when I can't use the square root property or the zero product property. So this is always my last choice. So let's take a look at what other choices you would have. Initially, when you look at this, you say, I can't use the square root property because what I have on the left side isn't something squared. So you'd go ahead, because it's set equal to 0, and try to factor this. So if you factor this, you would get 2x plus 3 times 2x plus 3 is equal to 0. Notice, whenever you see a perfect square here and a perfect square here, you want to check to see if perhaps this is what we call a perfect square trinomial. Trinomial being 3 terms. What do you square to get 4x squared? 2x. What do you square to get 9? 3. 2x times 3 is 6, and notice your middle term is double. 2x times 3 is 6x. Your middle term's double that. So that means both of your factors, 2x plus 3, are identical, which means this is a perfect square. You can write this as 2x plus 3 quantity squared equals 0. So lo and behold, after one step, you can use your square root property, because in this case, you have a perfect square on the left side and a constant. In this case, the constant is 0. So here's your constant, and u happens to be 2x plus 3. So I square root both sides, and I get 2x plus 3 equals plus or minus the square root of 0. Now, in this case, 0 only has one unique square root because 0 doesn't have an opposite that's different than itself. So in this case, you get 2x plus 3 equals 0. You're going to get one answer, and that's because both of these factors are identical. Okay, whatever works for this first factor for a solution for x will also work for this one. So in this case, 2x equals -3, x equals -3 halves. So we only have one solution. So you can see I could have either used I had a factor in order to recognize this. Once I've done the work to factor it, I'm just going to set that factor equal to 0, like right down here, and just do my solution. I wouldn't even use the zero product property. Okay, let's leave 5, and let's go to D here. D is a quadratic equation, and notice I'm giving you a hint. Your constant term is 0. And so whenever your constant term is 0, remember the general quadratic equation looks like this, set equal to 0. So in this case, we only have our first two terms. We have our term with our x squared in it and our term with x. We call this the quadratic term and the linear term. Anytime you have this type of equation, boom, you can factor it quite easily because all you have to do is pull out a common factor. It will always have the variable, in this case, x, always in common. So that's all it happens to have in common. So when I factor the left-hand side, I get x times x plus 1 is 0. So I set each factor equal to 0, and I solve that equation. Well, this one's all done for me. And here I have to subtract 1 from both sides. So there are my two solutions. No quadratic formula, okay? No need to go through all of the pluses and minuses and square roots and simplifying all the things we have to do when we use the formula. All right, now D, look at D. Does that look like this? Does it look like that? Take a minute and think about that. Okay. The answer is it almost looks like that. And the key difference here is the fact that this would be u. U in this case would be the quantity x minus 7 because that's what's being squared. The problem is that there's a number multiplying u squared here, multiplying the quantity x plus 7 squared. And in this square root property, notice we have a 1 out here. So the first thing you have to do whenever you're using the square root property on equations like this is that you want to divide both sides by whatever that number is that's multiplying the perfect square. We call that number -2, and that's called the coefficient. So now we have x minus 7 squared equals 10. And now you're all set to use your square root property. So u here is x minus 7 when you take the square root of the left side and you have plus or minus the square root of 10. And now to solve for x, there's one more step. You add 7 to both sides and you get x equals 7 plus or minus the square root of 10. And that's your two solutions right there. So you would say 7 minus the square root of 10, comma, 7 plus the square root of 10 if you were entering the answer into my math lab. So this saves a lot of work. I've seen students do so much work on these. I've seen students do this type of thing. Sometimes students will recognize dividing both sides by -2 and sometimes they don't. So the first thing they do is they square this out, and hopefully that's done the correct way. So I always encourage you to do it the long way by writing down what it means to square that. And then if you square this properly, this is what you'll get. And then students multiply everything through by -2, and then they will now subtract 20 from both sides, and then they'll use the quadratic formula. My goodness, look at how big these numbers are for the quadratic formula. So as you can see, being able to have a variety of ways, some flexible ways, and a number of approaches to solving these equations is very helpful. All right, so finally here, what do we need to look at? We need to look at C, and it says write your exact solutions and then use your calculator to make a decimal approximation to the nearest hundred. So what that tells me is that under the square root symbol, I am going to have something that's not a perfect square. So I will have two irrational numbers for the exact solutions, and then I can do an approximation to each. So the first thing you have to determine when you look at this equation, after you decide that it's quadratic, is which side do you want to have the 0 on? It does not matter. You can decide to bring everything to the left-hand side of the equation like this, or you can decide to subtract -5x squared from both sides of the equation like this. It doesn't matter in the end. It looks a little different, but the solutions are exact, because you'll see a little dash, a minus for negative in a different spot, but it's all the same. So because when I start to solve a quadratic equation, I always put it in this form to see if I can factor it first. So this tends to be my approach. But other students say, well, hey, look, I'm going to throw the 5x squared, I'm going to subtract it from both sides, put it on the right side, and that's only one step. So again, it's totally up to you. I just want to encourage you, if you don't believe me, to try it both ways. In the answer key, I've put both solutions in, and you can use your calculator to show that they are the same. So first you want to identify A as 5, B is -20, and C is 6. And now let's take a look at something that's very important. When you solve an equation, you go from one equation to an equivalent equation in this case, right? So these two equations are equivalent. You have the right to subtract 20x and add 6 to both sides. When you write the quadratic equation, I beg you, please, you are solving this equation for x. So the very first thing you should write is x equals the opposite of b plus or minus. After that, I don't care. You can use your equal sign forever and ever until you get to the end. But this first step is crucial because you're solving an equation right here. You want to have x equals. And then from here, you can do all these equals. All right, so the opposite of b is 20, since b is -20, plus or minus b squared. Well, -20 times -20 is 400, minus 4 times a times c, all over 2 times a. Okay, 20 plus or minus the square root of 400 minus 20 times 6, which is 120, all over 10, equals 20 plus or minus the square root of 280, all over 10. And so to simplify this radical, I need to find a factor, a number that divides it, that's a perfect square. So on the side of my paper, I have a quick list of my perfect squares, maybe up to 100, just to look at. And the first thing I notice is that 4 will divide into 280. So I know I can use 4, so now I continue with my equal sign. I get 20 plus or minus the square root of 4 times the square root of 70, all over 10. And now I get 20 plus or minus 2 square roots of 70, all over 10. And now I say 10 is my common denominator for both of the terms on top. So that means that 10 goes with both of them. So I separate it out so I can avoid making an algebraic mistake where I just would say take 20 and divide 20 by 10 and then forget 10 belongs to the 2 square roots of 70 too. It belongs to both of these. So this equals 2 plus or minus 2 goes into 5, 2 goes into 10 5 times. So that's the square root of 70 over 5. So these are the two solutions. You would write them like this: 2 minus the square root of 70 all divided by 5, comma 2 plus the square root of 70 all divided by 5. So these are what we call the exact solutions, and this is how you should always leave your answers unless we're working with a problem, an application problem, and I asked you to round it off. In this case, I've also asked you to use your calculators to round to the nearest hundredth. Okay, so in this case, if you do that, you're going to get x is approximately 0.33 and x is approximately 3.67. So these are our estimated solutions, our estimates. Okay, so as you can see, the quadratic formula is fantastic, but you have to be very careful as you work through not to make some arithmetic mistakes. So those are our quadratic equations for lesson 7. Let's take a look now at the polynomial equations. So polynomial equations can sometimes be solved by factoring out the greatest common factor and using the zero product principle. The most important thing is that you don't ever divide both sides of your equation by the variable, any power of the variable, because when you do that, if one of the solutions for your variable is 0, you are dividing both sides of your equation by 0. And the other reason is because you will lose one of your unique solutions for your equation. So you never want to start off by, in this case, by dividing both sides by x squared, or in this case, dividing both sides by x. Because then you've made this 4th-degree equation into, when you do that, into a quadratic. So this equation will have more solutions than a quadratic generally, and same here. This equation can have up to 3 solutions, and this equation can have up to 4 real solutions. Okay. So the first thing you want to do is you always want to set any polynomial equation equal to 0. Because if you can solve it, the only way you're going to be able to solve it is by factoring it. In this case, you have your greatest common factor, which is really your greatest common friend, because it's going to get you to the solution very quickly. All right, so I see x squared here as a common factor, and then when I pull the common factor out, I end up with this factoring problem where x squared is like my a, and this whole quantity here, x squared plus x minus 6 is like b, but I'm not done. I can keep factoring this. X plus 3, x minus 2 equals 0. So now what I have is a times b times c is 0. I have 3 factors that I set equal to 0 and solve. So x squared equals 0 is a baby quadratic equation that has one solution, x equals 0. It has a twin solution because 0 and 0 work, but 0 and 0 are identical. X plus 3 equals to 0, x equals negative 3. X minus 2 equals 0, x equals 2. So my solution set looks like this. Negative 3 is my smallest solution, then 0, and then 2. So as you can see, greatest common factoring is the key for these polynomial equations. So when you're looking at your sheet that we gave you at the end of the packet where you have a bunch of different equations, and we're asking you to write out your strategies with a couple of examples, this is the idea you want to write beside polynomial equations. If you haven't discovered that yet, look at the end of your packet number 1, and you'll see the equation summary sheet, it's called. Okay, again, this one, x cubed minus 16x is equal to 0. That's step number 1. GCF, step number 2, GCF, 1 is set equal to 0. X times x squared minus 16 equals 0. These are so nice and easy to factor because it's the difference between 2 perfect squares. x plus 4, x minus 4. So x is 0 and x is plus or minus 4. So our solution set looks like this. So as you can see, the skill of being able to factor and recognizing different types of factoring is very critical to solving these equations. You'll be using factoring throughout the class. So this is the time to really spend some time making sure you can do some factoring examples. Okay, and finally, even though we started off a demonstration with the absolute value equations, we've saved them for the last year. So the key to absolute value equations is to isolate your absolute value on one side of the equation and your constant on the other. Okay, so now you have the absolute value with some kind of stuff inside, an algebraic expression. Then remember, you're going to convert the stuff, this equation, to two equations where the stuff inside is equal to the opposite of the number and the number itself. So the stuff is equal to the number, the stuff is equal to the opposite of that number. Again, realizing you've isolated this. This is isolated. What do we mean by that? There's a coefficient of 1 in front, right? There's a coefficient of 1, and there's nothing being added or subtracted from it. So you need to get that absolute value all by itself before you can start to use this idea here, like similar to like what we did with the square root property. So when I look at this property, this equation, the first thing I do in my mind is I just like, in this, I always like to use colors. So if you have some colored pens or whatever, highlighters, I highlight the absolute value right away. And then I say, is there anything on either side of it, anything multiplying it? And if there is, I need to deal with it. So in this case, I have to deal with the fact that 4 is being added to that yellow blob. So I got to subtract 4 from both sides. So my equivalent equation to this is the square root of 6x, excuse me, the absolute value of this 6x minus 2 is equal to 28. All right, that's step 1. Now I remembered all the work we did in the demo to show that an absolute value equation, when I graph it, and then, so if I took this and graphed it, and then I made a horizontal line through 28 up here, like way up here at 28, so y equals 28, and then 6x minus 2, okay, would be something like this. Remember, we're finding where these two things intersect. We have two answers. So recall that the idea was to take the quantity inside 6x minus 2 and set it equal to 28, and to take 6x minus 2 and set it equal to negative 28. Notice we're not changing any signs in here. We're not multiplying anything. We're just taking the quantity inside the absolute value and setting it equal to the plus and minus value of this constant. And from here, you can all solve this because they're just linear equations. And I reduce this, negative 26 divided by 6 is negative 13 over 2. Okay. So my solution set looks like this, negative 13 halves, comma 5. Now, this next absolute value equation, again, I just simply highlight the absolute value part. Try not to highlight anything else. There we go, even though it looks like I got a little bit into the 3. So I look at that and I say, I want that yellow blob all by itself. So I have to undo the subtraction of 4, and I have to undo the multiplication by 3. What I am not going to do is to think of these absolute value bars in any way like parentheses and distribute the 3. No way, okay? These absolute value bars, think of them as heavy-duty steel trap doors, and that you can't get anything inside of there. You're going to be able to remove those doors once you tell it what this equals. But right now, they stay right around the 2x minus 5. So I'm going to add 4 to both sides. and I'll get 3 times the absolute value of 2x minus 5 equals 33. And I'm going to keep my little yellow blob with me. It's going to follow me. That's my expression inside. This is my stuff right here. And now I divide both sides by 3. And now I get my absolute value with my stuff all alone on the left side and the constant on the right. Okay, that's your goal, your initial goal. Now you can drop the gates and say, well, now 2x minus 5 will be freed if I set it equal to 11 and if I set it equal to the opposite of 11. So 2x equals 16, x is 8. 2x equals negative 6, x is negative 3. So my two solutions are negative 3 and 8. Okay, so that wraps up the class activity for lesson 7. If you have any questions, just shoot me an email. Thank you. Bye-bye. Whoops, I just noticed that I made a mistake here. And I skipped a step. 6x equals negative 26. If I divide both sides by 6, I get x equals negative 26 over 6. And when I divide the numerator and denominator by 2, I get negative 13 over 3. So this should be a 3 here, negative 13 thirds. So I'm glad I caught that before I downloaded the video. Okay, if you notice that I've made other mistakes, please let me know so I can notify our other classmates.